Day 230 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 230, and today we have question number 106, construct binary tree from Inorder and Postorder traversal. The difficulty level is medium, but don't worry, we're going to keep the solution as simple and easy to understand. So let's get into it and see what the question says. The question says, given two integer arrays Inorder and Postorder, where Inorder is the Inorder traversal of a binary tree and Postorder is the Postorder traversal of the same tree, construct and return the binary tree. So if y'all been keeping up with this channel, you know we did a similar question yesterday, but today we're doing the Inorder and Postorder, where yesterday we did the pre-order and Inorder. But it's kind of similar, and I'm gonna show y'all why. Now, the first thing we need, let's look at example one. And the first thing when looking at example one, we need to understand is what is an Inorder traversal and what is a Postorder traversal, right? So the Inorder traversal is we just traverse the left side of the subtree recursively, then we visit the root node, and then we traverse the right side of the subtree recursively, right? So we go like this. We start and do the left side, then we do the root, then we do the right side. So that's where it goes. That's why it's 9. We get the 9 right here when we do the left side. Then we do the 3, because the 3, then we do the root, and the root is 3. So we do the 9, 3. Then we do the right side, traverse the right side recursively, and that's where we get the 15, 20, and 7 from right here when we traverse through the right side. Now that's how we do the Inorder traversal. Now how we do the Postorder traversal is first we traverse the left side. That's why we have this 9 right here. Boom. Then we don't do the root next. In the Inorder, we do the root next, but in the Postorder, we do the right subtree next, right? So first we do the left subtree, then we get the 9, then we do the right subtree, and that's where we get the 15, 7, 20 right here. Boom. 15, 7, 20, and then we do the root after we did the left side, then we did the right side, and then we do the root last, which is important when we're going to try to figure out how to traverse or how to find a root and how to create the new binary tree from these two inputs that we have right here. So let's go through the inputs just so we can make it make sense. So in the input, we have the Inorder is a array of integers 9, 3, 15, 20, and 7. And I just explained how we got those. Same with the Postorder. The Postorder is equal to an array of integers 9, 15, 7, 20, and 3. Now I explained how I got those. Now, from those two integer arrays, we have to create or construct a binary tree, and that's why the output is 3, 9, 20, 0, 0, 15, 7, which is the code representation of this picture right here, right? So the binary tree, you already know we start from the root, then we do the left, then we go left to right, and then we go left to right again. So just so y'all understand where these nodes come from, first we do the 3, which is the root right here. Then we do the 9 and the 20 right here. Boom. Now you see that 9 doesn't have a left child node or leaf node or right leaf node, right? So that's where it's null. The null comes from because the left side of 9 is null and the right side of 9 is null. Then we come over and do the 15 and 7, which is the leaf nodes of the 20 right here. So it goes 15, 7. So it goes 3, 9, 20. If there were nodes right here, they would be that, but since it's not, it goes 3, 9, 20, null, null, 15, 7, and that's how we got the output. That's what this picture represents. So now let's figure out how we got this from the information that they gave us, right? So let me copy and paste this over here. Boom. So I'm gonna copy and paste this. That's the Inorder. Now I'm gonna copy and paste the Postorder. Boom. That's the Postorder right here. Hold on. So now we have to figure out how were they able to construct this binary tree from this information of arrays, right? So I'm gonna show you how. Now with the Postorder, we know when we're dealing with the Postorder, first thing we do is, excuse me, y'all. First thing we do with the Postorder is we traverse the left side, then we traverse the right side, and we do the root last, right? So since we do the root last, we can look at the post order and we know this 3 is the root right here. Boom. So we could come down here and we could just set the root to 3, because since the 3 is last in the post order, we automatically know that that is the root node because of how the post order traversal works. Boom. So let's just build our tree, right? Boom, get our tree going. So boom, we got the, excuse me, y'all. I don't know why. Well, oh well, that'll work. So we got the tree going. So we got the root. Now we have to figure out what goes onto the left subtree and what goes onto the right subtree. So now we have to look at the Inorder, because we know how the Inorder goes. We know with the Inorder traversal, first we traverse the left tree, then we then we visit the root node, and then we traverse the right subtree, right? So looking at this Inorder, we see the 3 is right here, and we know the 3 is the root, right? Because it's the last in the post order. So we look to the left of the root to see what's going to be on the left subtree. And since there's only one element or one value on the left of the 3, we know that that's the only value that's going to be on the left subtree of the binary tree that we're creating. So we could put the 9 right here. Boom. So now we're just left with the 15, 20, and 7. Now in the post order, the value or the integer next to the root, or the second to last value in the post order, is always going to be the root of the right subtree, right? Or the child node to the root, right? So this value right here, whichever is second to last, is always going to be the child node, or the root of the right subtree, the child node to the root, or the root of the subtree, right? So 20 is all, or in this example is 20. We know 20 goes right here because it's to the left of the root, right? And because of how the post order works, we traverse the right, then we traverse the left. And if you pay attention, when first we traverse the left, then we traverse the right. And if you see in the post order, when we traverse the right, we go 15, 7, then 20. So 20 is, and then 3. So 20, or this node, is always going to be the child node to the root. So that's how we know we're going to put 20 right here. Boom. So now we have the 9 and the 20. Now we have to figure out where the 15 and 7 going to go. So we're going to go back into the Inorder, and we're going to look at the Inorder traversal again, and we see that the 20 is right here. So when we look to the left of the 20, if we kept going, it might be more values, but we know it's only 15, and then after the 15, we're back at the root. So we know that the 15 is the only value, or the only value on the left subtree, or to the leaf node to the 20. So we know that we could put a 15 right here. Boom, because it's to the left of the 20 in the Inorder, right? And same with the 7. Since we know that the 7 is on the right side of the 20, we know that that's going to be the right value of the child node to the 20, and the 20 is going to be the root of the subtree, right? Same thing we did over here, we're just going to apply it to this. And since we already did these numbers, we know we don't have to do them again. So we know that this is all we have to work with. So we see that the 15 is on the left. Boom. So we put the 15 right here. Put the 15 right there. And then we put the 7 right there, just like so, right? And then now we have our binary tree. And if you see, it's the same thing as over here. It goes the 9, then the 9 goes to the 3, or the 9 is the left subtree of the 3, and then the right subtree from the 3, or from the root node, is 20, 15, and 7, like it is over here. And that's how we got it. That's how we figured it out. That's how we were able to create our subtree from this information that they gave us. Now that we know what it is that we're trying to do, we still have to figure out how we are going to code this. And don't worry, y'all, it's not that difficult. So let's get into the solution now so I can show, or matter of fact, let's look at example 2 though, just in case they try to throw some tricks our way. In example 2, we have the input Inorder equals an array of integers -1, post order equals an array of integers -1, and the value is -1. The output is -1 because it's only one value. So it's only one, if it's only one value, that means it's only one node. And if it's only one value in the in order and that's the same value in the post order, it's only one value. So there's only one node, which is -1. So now that we understand the examples, let's get into the solution. But before we get into the solution, y'all, if you need any new Apple AirPods, go ahead and check out the link in the description, and then go ahead and like, comment, and subscribe. So now let's get into the fun part, y'all, the actual code. Code is not that difficult, y'all. We'll get through it. And the first thing we need to do with the code is we need to create a base case that is going to check if the arrays are empty or not. And if yes, we'll just return nil, and that means there's no tree to build. So first thing we are going to do is we are going to say guard let root. So first we need to find the root, right? So we're going to say guard let root value equal post order dot last, because remember, the root is always going to be the last value in the post order, right? So we're just going to say guard let root value equal post order dot last. So that's how we're going to find the root off the top, right? So then we are going to say, but we're going to say comma. We come underneath that and we'll say, just for make it easier to read, we'll say let root index equal in order dot first index, open up the parentheses, where colon, open up the brackets, we're going to say $0, which is going to help us to iterate through every element in the array, is equal to root value. So this is going to allow us to find where the root is in the in order traversal, right? We already know that the root value is going to be the last in the post order traversal. So now we have to find where that same value is in the in order traversal. And right here is the 3 is right here, and this is how we're going to find it. We're going to say let root index equal in order first index where this root value that we just created up here exists, so it's going to traverse through this, and as soon as it sees this 3, it's going to know that this 3 is the root value. Then we're going to come outside of that and we're going to say else. We're just going to return nil. Boom. Then now we need to create a new tree node for the root of the subtree that we're about to create. So in order to do that, we're just going to come down here and we are going to declare a variable called node. We're going to set that equal to a tree node. Open up the parentheses, root value, just like that. Boom. Now we need to recursively build the left subtree, right? So we're going to say node.left equals, build tree, which is right here. This is where we're getting from. We're using some recursion. Open up the parentheses. We're going to say array, open up the parentheses, in order, open up the square brackets. We're going to say 0 ... up to, boom, just like that, root index. Come outside of that parentheses, but inside the other parentheses and say comma. But what this is going to do is the last this is going to do is the left subtree in order traversal is everything to the left of the root index, right? So this is how we're going to know that everything left of the root index is going to be the in order traversal of the left or the left subtree's in order traversal. So now what we need to do is find the left subtree's post-order traversal, what we need to do is the left subtree's post-order traversal, which is going to be the first root index element of the post-order array. Excuse me, y'all. So in order to do that, we're going to say array, open up the parentheses, post-order, open up the square bracket 0, then we'll say up to root index, just like that. Excuse me, y'all, not just like that. I spelled that all wrong. Root index, just like that. And that's how we're going to find the the that's how we're going to find the left subtree's post order traversal, right? Because it's going to be the first root index element of the post order array. Then after we do that, we can come outside of these parentheses now, and now we need to recursively build the right subtree. And the first thing we do to do that is we have to check if there are elements for the right subtree, right? So first we're going to say if root index plus 1 is less than inorder.count, like that, we're going to say let last post index equal post order dot count minus 1, right? So the last element of the post order is already the root, right? So now what we need to do, excuse me, y'all, is we need to, I'm trying to think how we're going to do this. Oh, my bad, y'all. My brain went blank for a minute. We're going to say node dot right equals build tree. So we're going to use some recursion, and we're going to say we're going to find the right subtrees in order traversal is going to be everything to the right of the root index, right, in the in order array. So to do that, we just need to say array, open up the parentheses, in order, excuse me, open up the square brackets, open up some more parentheses. We're going to say root index plus 1. Come outside of the parentheses, just that one parentheses, and say dot, dot, dot. Then we're going to come outside of that square bracket and that parentheses. We're going to put a comma, and we are going to do the same thing. We're going to say find the right subtrees post order. So this is the in order. Now we need to do the post order traversal, and that's going to be the element from root index to the second to last element, because remember, it goes up to the second to last because the last in post order is going to be the root. So we're going to go up to the second to last element in the post order array. So in order to do that, all we're going to do is we are going to say array. Hold on, y'all. Hold on. What I just do? Oh, my bad. Over here. We're going to say array. Open up the parentheses, post order, because we already did the in order. So now we're working with the post order. Open up the square brackets. We're going to say root index dot dot up to last post index, which we created up here. That's why we created this, because we want to go to the last or the second to last index in the post order array. So now that we did that, y'all, we could just come underneath this right here. Let me clean this up a little bit so it could look nice for y'all. What? Never mind. I should have just left it alone. I'm just leave it. Yeah, see, never mind, y'all. I'm gonna just leave it alone. But we just come right here, and we are gonna just say return. We're going to return node, just like that. So let's run it, see how it runs. Let's see. Yeah, see, my bad. I put too many spaces. I can't do it like that. I was trying to clean it up for y'all, but they don't want me to. Oh, shoot. Index. Then it's going to be up to, just like that. I don't know why it's looking like that, but it can't be any spaces between these dot dot up to and the up to sign. You know what I'm saying? You just have to leave it how it is. So now let's run it, see how it runs. Let's see. And it's accepted, y'all. So let's submit it, make sure it stays accepted after we submit it. Let's see. Ooh, look at that, y'all. 23 milliseconds beat 25% of users with Swift, y'all. Not too bad. We'll get those numbers up as we continue down our LeetCode journey. But right now, we just want to get to the point where if a problem is presented in front of us, we're able to solve it. And I feel like we solved this with a simple, easy solution that everybody can understand, y'all. So that's why we did it like this. I hope y'all learned something today. Before we leave, though, get one more look at the code. One more look at the code. It's not that long. It's not that long, y'all. Hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.